Well, this is my original old radio system. It's an I2C controlled FM receiver. I told you before in another video, but this is the programmer debugger for this microcontroller, the STM8S103 8-bit microcontroller, very versatile. And this is the FM receivers. This is a single chip with 10 pins. The pin distance is different from the breadboard. It's smaller, so I had to create myself a small PCB and solder those 10 pins to the PCB. The serial port connected to the microcontroller, I do not use it. This is another project. It doesn't have to do anything with the FM transceiver, so you can forget this. Only the speaker is connected. And this is the audio amplifier. This is the audio output from the FM receiver. Left gray, right white, left right audio. The left audio is going to my audio amplifier, and then it's not going to this speaker, but it's going to some experimental speaker or whatever, but it works fine. But I want to create a more complete system. I want to integrate the audio amplifier into the board, so I created me another board like this. This is the audio amplifier. There are many investigations done. Let's have a look inside. Also the same Lego system is there. For extra stability, I made another connection here in the middle. And then first the antenna. It's about 100 megahertz in FM, so it should be about a quarter antenna as a length of 75 centimeters. I just drilled a hole. I will put off the audio. So I just drilled a hole of 2 millimeters, so the copper wire can go through 3 millimeters. Then I damage this Varo clamp, so 2 millimeter only the copper wire, and it's terminated here. And it's going to the antenna input of the FM receiver. I also, on the old one, I had different PCBs used for the microcontroller and the FM receiver. But on the new, I put them both on one single PCB. It just fits very nicely. I struggled a lot with, because the microcontroller is transmitting data through I2C protocol, but the FM receiver, you can communicate it with SPI or I2C. If you communicate with I2C, you have to put a 10 kilo ohm resistor between pin 3 and ground. Otherwise it expects SPI. And I experimented a lot. I didn't get it working because I forgot to make pin 3 by a 10k ohm, put it to ground, and finally then it works. So also the audio amplifier, this is the standalone one. I made myself another one and I integrated to the whole system. I always use this same. There's another way of with tie wraps using to connect it to the board, like here. I did not like it here using a copper strip, but it's free enough. I can put it out here. I could also have soldered these two wires on the underside of the board, but I like to have it modular. I can easily replace it or remove it. I shortened the wires. This is the audio. So this is my programmer debugger. I also used a, well, yeah, it's sorry. general ground. I also put the ground connections below the board, so it makes it all very clean. This is a central board. You can put anything in ground you want. I also experiment with some on-off switch, on, off. It's not connected to anything. It's a vertical 3D model. I experiment with it. I will use in future. This is the speaker system. This is the original speaker system. This is the new speaker system. 2 Wago clamps on this board. I use these Lego clamps, so the speaker is not glued or whatever to this board. It's just clamped in between these 4 pins. They fit very nicely. Well, it's not good for the sound quality, but it's more to make it modular. Here's another on-off switch. It's not used. It's the battery pack containing 2 batteries, and I can I've connected it now. For now, I disconnected the programmer, otherwise we have a conflict of power, but I connected the power supply, so through these 2 wires, the amber wire, because it's 3.3 volt, and 0 to ground, to the microcontroller. And it all works fine. Especially the antenna system I like very much. Well, this is my second video on this FM receiver. Maybe in future I will add some more videos. Thanks for watching. I must make a small rectification. I call these 2 items where the microcontroller and the radio receiver is on, I call these PCBs, and now put together on one, but this is of course not a PCB, it's called a breadboard. I also want to explain how I soldered the FM radio receiver, this one. I try to use pin headers, but they don't fit, and I always forgot 1 pin. It should be 5 pins and not 4. So from this perf board I saw me a piece between you just have to fit it, 5 by 4 holes, and then I solder it, the 5 wires on both sides, and now you can easily put them on this breadboard, so the connections are on both sides of the middle section. Thanks for listening again.